Great. So it looks like we're at 3 o'clock here. So thanks everybody for coming and get yourselves comfortable. As I was just saying, due to the large number of registrations, unfortunately, we won't be able to accommodate the raise hand feature today. So if you do have questions, please put them into the Q&A box and we'll be monitoring that throughout the presentation. So this is another Weather Band webinar. We're so thrilled to have both Bryan Norcross and Nicole Mitchell here with us today. A huge thank you to both of you. If you do need more information about the Weather Band in general, please visit amsweatherband.org. I'll drop that link into the chat as well. But again, thank you for being here, and I will hand it over to Bryan, who, being an award-winning hurricane reporter, needs no introduction on himself. As the Times article has already called him the most trusted hurricane human on the planet. So thank you both again so much for being here, and I'll hand it over to you, Bryan.
All right, Tiernan, thanks so much. And thanks everybody for joining us today. And it's my pleasure to introduce to you Lieutenant Colonel Nicole Mitchell, former commander of the 126th Weather Flight at the National Guard. She worked as a military forecaster in Europe in support of operations in Eastern Europe and the Middle East, and weather officer for the hurricane hunters from 2003 to 2019. Nicole was flown into some of the strongest and most impactful storms of the past 20 years. She also works in media in a number of cities, including at the Weather Channel, where Nicole and I worked together for a little while. And currently she's working in the Twin Cities for NPR and also KSTP, the ABC station there. So Nicole, let me turn it over to you, and then we'll open the floor for questions. And I have a few questions of my own. Good to see you again.
Yeah, you as well. And thank you for helping put this on today. Of course, we're doing it today and this week with the hurricanes because it's Hurricane Preparedness Week. So of course that season is just around the corner. So I have some slides and some stories to tell, but we'll also be monitoring some of the questions as well. So I'm happy to get it interrupted a little bit and go from there. So I don't know how many people in our audience today are also military. I have almost 30 years now between the Guard and Reserve, but so I do have a slideshow to go along with all of this. And hold on, let me get that back on share screen first. There we go. Where's my slideshow? Okay. Technology, gotta love it. Okay, so for those of you familiar with the military, the first Hurricane Hunter flight started as so many things start in the military, which was a bar bet using the then technology at the time and more instruments. It was, can we fly into this? And they knew there was weather around, and they ended up flying right into the eye of a hurricane. Now, if you have to think of this was back in the 40s in World War II, so there wasn't a lot of data at the time. Up until the 1960s, we didn't have the widespread satellite coverage. We couldn't see things coming. So what was coming and how intense, and then even less communication with World War II going on at the time. So that was the context of this. So they fly into this storm, prove they can do it, and then realize as they end up in the eye of a hurricane that that could actually be worthwhile for something. So they went back and dragged the weather officer back in the plane, and that's how we got our first hurricane flights. Of course, they've gotten much more technologically advanced since then. So what the Hurricane Hunters are flying right now is the WC-130J model up until about 2004. So I had a couple of years where we were in the H model, which was a plane that was from the 1960s. So it was interesting. The air conditioning, the insulation wasn't really good. So if we were down at low levels, which we are sometimes on the storm flights, we would actually be in the tropical weather, even in the plane. The air conditioning couldn't keep up. We were all sweating. And then we do some winter storms and we'd be up at 20 or 30,000 feet. We'd all be freezing. So it was just for comfort. I like the C-130J. The pilots, of course, like it because it's a nice glass cockpit now and a lot of extra features in terms of all the instrumentation. So as I mentioned, before I get into the hurricane stuff, I do want to mention that what do hurricane hunters do when it's not hurricane season? We are actually part of the National Winter Storm Operations Plan, and have over the years flown out of Alaska, Hawaii, California, some other places. Right now, it's really targeted on atmospheric rivers and getting those big trains of moisture before they hit the coast. But for that, you want to be as high as possible. And it's been instrumental in getting some of the moisture when you get those big California storms, for example, like how much moisture and where it's going to go, and if there's the potential for flooding or things like that. So that's another part of the mission, and it is done in the off season. Also nor'easters sometimes, because it's the same problem as hurricanes. You just don't have as much data over the water. So this is looking at the West Coast still, but you'll get a grid. And the big thing with that is dropping the sondes, and I'll talk more about those later, but those are the instruments that we drop down from the plane that get temperatures and pressures and winds and all those things, and collecting all that data with the storm and ahead of the storm environment to help forecast how intense it's going to be, where it's going to go before it hits the coast. So West Coast storms and nor'easters, a lot of times we will do that. So that's kind of a look at how we would stagger the odds, perhaps ahead of a storm as it was coming into the coastline. And that helps with the forecasts, anywhere from a day out to several days out, especially with some of those big impacts. So that part of the mission runs from December through April. Okay, and then there is the hurricane operations plan. And someone asked if the drop sondes are recovered. They are not. They are made to be biodegradable. There's kind of a compressed cardboard tubing with them. The instrumentation inside is metal, but they are going to go off into the sea most of the time because we wouldn't be launching them over land. We launch them over water, and by the time you get all that instrumentation into the salt water and everything else, even if we were able to recover them, they just really wouldn't be worthwhile after that. Okay, so for the National Hurricanes Operation Plan, which of course is the bread and butter of the hurricane hunters, 24 hours a day operations and up to 3 storms at a time. And the reason it's up to 3 storms is because in theory, if able to, we could do more. So if somehow all the storms ended up in the Gulf and Caribbean, for example, and we're kind of close enough to each other, it might be possible to do more. But a lot of times what that's going to mean is you could have one storm in the Gulf, one way off in the Caribbean or the Atlantic, maybe another storm in the Pacific. And by the time you take all the crews and the planes available and start divvying them out and then have to do the round the clock operations, that is we can handle this. And then anything after that is going to be, as we're able to do it. If it was a particularly intense storm season, it would just be prioritized as to where the resources were going. And with notification, of course, the hurricane hunters have meteorologists always in contact with the hurricane center. And so you usually know when something's coming. But if something does develop quickly, we can get up to a 16-hour response time. You have to give people 12 hours to crew rest and then actually get going and get to the storm. So that's where that comes to. Let's see. Okay, so these are all the areas we covered, and that's why I said it can be 3 storms at a time, because they could be anywhere in this. So the Gulf, the Caribbean is usually what we're hearing about, but once storms even start rolling off of Africa and get to the east of the Caribbean islands, the Antilles and whatnot, we'll start taking those storms even outside of there so that there's a little bit of history before it starts impacting land. Now for the Pacific side of that, it's a little more hit and miss. There's a lot of storms that don't get flown because if they develop in the East Pacific and they're far enough out from land, sometimes they will just steer off to sea. if it looks like they're going to be turning into Mexico or headed up the Baja of Mexico or of California, something like that, then they will get flown. And then sometimes even if they head off to sea, they will get close enough to Hawaii. So for those storms, it's really going to depend on where they are as to how it's decided to fly those or not. So you can see, depending on where the storms are, there's different bases of location. Part of the reason we use that C-130J is because it's big and it's solid and it can hold over 14 hours of gas. So an average storm mission is about 10 hours, but C-130s aren't particularly fast. So if you're looking at going to Hawaii, it might take 2 days just to get in place with the gas and refueling and the crew rest time. Same thing to St. Croix, it's about a 5-hour flight. If you've already flown that far with your gas time, something in the Atlantic, you can't get there and back to the main base of the hurricane hunters, which is Keesler, in the same day or with much flight time in the storm. So you're gonna go to somewhere like St. Croix and reposition. If it's an East Coast storm, we might reposition up the East Coast so that there's enough gas to get to the storm and really spend a lot of time there, and you're not just wasting all your fuel time trying to get there and back, basically. So big plane, not a lot of people. The crew is a 5-person crew. And the hurricane hunters are unique to the Air Force Reserve in that the reserve is usually people like me, or same thing with the Guard, who have another job and kind of a separate civilian life, and then you come in part-time and do the military work. The hurricane hunters are unique in that it is half full-time people and then half of that more traditional reservist role, because especially during the active part of the storm season, you kind of need people available all the time. And then the reserve people will come in extra during the hardest storm season, and then whenever else you can. So, you know, a lot of us would come in multiple extra times during the season, especially if it was a busy season. So 2005, for example, when we'd gone into the Greek alphabet, you know, it was kind of all hands on deck all the time. So that 5-person crew is a pilot and a co-pilot, a navigator, the meteorologist, which is called an RWO, Aerial Reconnaissance Weather Officer, and then a loadmaster who actually has some training in weather data because they help with the SONs that are released that get that weather data back. That's the minimum. Sometimes there will be media on board. A lot of times the pilots especially will have an extra if it's a long flight or an overnight flight so that they can trade out and get a little bit of rest. And usually we have some people in training. So for example, if you had a meteorologist in training, you would have an instructor meteorologist with a student meteorologist. So a lot of times there will be at least 6 or 7 people on the crew and then any media. But typically, we're not going to take even our maintenance personnel during storms. You don't want more people than you have to have unless it's like an evacuation sort of situation. So just check the chat. So here is the birth of a storm, which is called a low-level investigation. At that, we will fly as low as 500 to 1,500 feet above the water, which is really, really low. But you're using that low level to kind of be right in the data, because of course, as the storms develop, you can be a little higher and get in the data. But if it's a lesser storm, if you're flying at 5,000 or 10,000 feet, usually it's on the millibar levels. So 850 millibars, which is about 5,000 feet, or 700 millibars, which is about 10,000 feet. You want to be as low as safely possible. So for an invest, we try and get as low as 500 feet. And my first storm actually was Hurricane Charlie in 2004. That was another very busy year, and all the storms were developing so quickly. They sent us out to do it, and I was a student at the time. And so I was the one watching the waves, and based on what the waves look like, you can tell how fast the winds are blowing. And I remember looking at the water, and you know, it was just supposed to be a garden variety tropical storm, and going, I think they're 80 knots. And then everyone looks out the window and goes, oh my gosh. And so we were at about 500 feet in a hurricane. That side of the storm had made it to hurricane levels, which is incredibly low. You shouldn't be that low. But that's one of the things that you're doing down there. The other thing that you're doing, and the reason you're flying so low and actually watching those winds so closely, is because on those missions, before you have a tropical depression or a tropical storm, you're actually looking to see if you can find all 4 wind directions, if you actually have a closed off circulation. So as you fly around kind of in a pattern to see if you have every side of the winds, then all that data is going back to the Hurricane Center, and then they can either say it's a tropical depression, or even, you know, it's already a tropical storm, or it's not quite there yet. You know, we'll just keep putting out our discussions on it, whatever else. I will say it does occasionally get a little political. So I've had storms that we didn't think were quite closed circulations, but especially if it's really close to land, they might call it a depression or a tropical storm anyway, because they want to be able to put out those watches and warnings and get everyone prepared. I also had a situation once, and I believe it was with Faye in 2008, where we definitely saw the closed circulation. And so I was about to go back and do what we call fix it, which is where you actually make the pattern to close it off. And I got called off. It was like, nope, don't go back. Just keep going. We were like, it's a circulation. And they were not ready to, they hadn't quite gotten the discussion. Usually if you watch those discussions, there's hints that, you know, it's about to be a tropical storm, or it's about to be a tropical depression. And because I guess there was a little unpreparedness, we were not allowed to close it off. I was working at the Weather Channel at the time, and I remember getting back from that mission, and one of our producers who had been following it on, you can watch the flights on Google Earth, he'd been following it, and he was like, what were you doing? He's like, I saw it, I could see the winds, and I was like, yep, they told us to go back. They weren't ready to name that one. So that's how it happens sometimes. Let me just catch up with the chat real quick. Oh, someone asked what image it was, and it was Tropical Storm Beryl. I will try and tell some of these images, although to be honest, some of the storms look alike sometimes, so I don't know every storm image that is in here. Okay, so that is the pattern that I was talking about. Now, if it's an invest, you're really, you don't know where the center is. Sometimes even if there is a center, it can be just miles of light and variable. So an invest pattern isn't going to look that nice and neat, but that is a fixed pattern, which is almost always coming in from whichever direction is most convenient. That usually isn't as critical, but you will always track that cross leg on the edge, which on this is on the right side. You'll always do that cross leg with the winds of the storm, so that you're not trying to kind of headbutt the circulation as you're repositioning to do your next cross leg. And it's an X like that so that you can get each quadrant of the storm, because different quadrants can be different shapes and sizes and have different intensities. So they can have very different feels to them. So that gives you a real 3D picture of what the whole storm is like. It lets you know which side might have the bigger impacts to it and things like that. So that's why we do a cross section. And usually if there's time, there's 2 cross sections, which doing all that flying takes about a 5 to 6 hour period. But by that, you've done 2 X's, means 4 legs, or 4 going through the center of the storm. So you've had also a history trend of where the center is going over that period of time, over those 5 or 6 hours, and a history trend of what the pressure in the center is doing. So is it dropping? Is it intensifying? Because one pass to the next, there could just be some anomalies or a little reorganization. But if you're watching it over several passes, you can really get a better idea of that trend. And as I mentioned, you can follow this on Google Earth. So this is what it would look like there, if you've ever seen that. All the yellows are showing 60 plus knots. And it's hard to see on this, but there's wind barbs on there. So a lot of people actually will follow the storm, and then it will plot the pressures as it's going along. And it's taking that from the different data that's coming out from the plane. So the plane has satellite communication. So it goes right from the plane to the hurricane center with all the data that we're getting. And so here's some of the types of data, if you've ever seen it. If you haven't, don't be overwhelmed. It actually makes more sense. So the very top line that says RECO, those we even take in training lines. That's just a quick observation that we take that's at flight level, pressures, temperatures, what we're seeing for clouds. It's just a quick and dirty. The second one down that's still in the blue, the HD obs, that's high definition. Those are compiling every 30 seconds, and that's just data from the plane itself. If the plane is noticing any precipitation or winds or anything else, but it bundles it every 10 minutes and sends it to the hurricane center. So that's more the fine-tuned data. And when they go back after a storm and review things, this is one of the things that they might review in kind of postpartum to see if there's anything in there. Now then the two things in white, the one at the bottom that starts with a bunch of XXA and XXB, that is the drop code itself. So if you've ever seen skew T code, it's very much like that. It's as the sonde is dropping to the surface, it's picking up temperatures, dew point depressions, winds. It's actually using the GPS so that if it goes from here to here, it can calculate, okay, that was a difference of this far. We can calculate it takes this type of wind at this type of direction, the speed and direction to get it there. So I will say I've had a few storms, and Katrina was one of them, where we were getting some weird data where the sonde was reporting in just a different area. And it was because the winds were so intense, it was actually spinning the sonde around the other side of the storm. So we weren't getting quite the data where we were hoping to get it from. And then on the right side, that's a vortex message. So that is where the person, so some of this data is automatic, but that one actually a person will write up, the meteorologist, and say the eye wall looks like this. This is any trends we're seeing. This is the actual pressure we measured. And this is the one that's most likely to go out to the world with a lot of information. So if you see the official pressure of a storm, this is where it came out of. That's that D line, 921 millibars. And this is taken from IOTA last year. Okay, just gonna double check on the Q&A. Just a couple questions. Private pilots cannot volunteer. It's military for a reason. There is some risk involved and liability, and it's just easier to send the military in, I guess. And are we still using navigators? Yes. So most planes do not have navigators anymore, or most of the J's don't have navigators anymore. The hurricane hunters actually have navigators by exception, because the meteorologists are so busy, the navigators, and there's just so much going on in a storm. It's really helpful to have that extra person. They help run the radars and have radar training so they can help us look at what we need to look at. They help with some of the GPS coordinates. When we fix a storm, I'm doing the vortex message, but they're fixing the coordinates. So they're helping build the coordinates for the next pass in, things like that. So that's why we have navigators, even though a lot of people don't. Are there plans to add more planes to the Hurricane Hunter fleet? Not that I've heard of. It's been pretty consistent, 10 forever. Yeah, it'll be interesting to see what happens in coming years with that. Volunteer opportunities for teachers. There is a website that the Hurricane Hunters produce. People can get tours. You can have a video feedback like this, but it is really hard for civilians to get on anything other than maybe an occasional training line, just because of the type of storm and the danger. As I said, like our own maintenance people weren't allowed to go most of the time, even though everyone does everything as safely as possible. You don't want to add extra people in the storm that are civilians. And as a woman, is it difficult in the field of meteorology? I'll be blunt. Yeah, so the sciences can still be challenging on women for a couple of reasons. There aren't as many of us. It's, especially within the military, there were many places that it was still a big kind of boys club, and then military and air crew. So yes, I have had challenges in my military career. It's just like anything else. I had some units that were fabulous. The unit I'm in now is great, and I'm actually the commander. So hopefully now that I've kind of gotten to that level, I can help make sure other people have a good experience and everyone's treated with dignity and respect. But as a woman in the military, I haven't always gotten that, especially early in my career, which was, you know, over 20 years ago. And so the culture is slowly getting better, but it's not perfect. There's also things, I don't think I get this as much because maybe because my credentials are pretty solid, but you'll get people that will say, well, I'd rather talk to a guy. It's like, you know, the women know just as much. So it can be challenging. But we're trying to get more women in all the time. And I do a lot of stuff with STEM, and especially trying to model for women so that more of them get in the field. Okay. The radar is from, images are actually from a radar on the plane. And I'm going to get to more on that in a little bit. Okay, so the dropson releases, here's how it looks. So flying as low as possible, but safely. So once you start getting moderate turbulent, you go up to at least 5,000 feet. And for a more intense storm, it's closer to 10,000 feet. Although that's a millibar pressure. So there's actually a crazy story. I flew Wilma, but not this flight. Wilma, when it rapidly intensified, had like, I want to say it was like a 3-mile eye. And it takes us going 100, and I think it was a 5-mile eye maybe, at 180 miles per hour. So we really slow down in storms to get as much data as possible. So that's a slow flight speed for a plane. That's 3 miles a minute. And so they were in and out of the eye of Wilma in just over a minute. So the eye is also where you can recover if things just aren't going right. And we're following a millibar, so a standard pressure curve, which, as I said, averages at 5,000 if everything is calm. But in a hurricane, the pressure curve is going like this, right? As you go through the eye. So they had dropped from going in at about 5,000 feet to about 3,000 feet, found out it was a Cat 4 or 5 rapidly intensifying. So they were way too low for that. And they couldn't even get leveled off fast enough in the eye before they hit the other side. So that's how quickly that pressure curve can change and how the eye size can make a difference. But as you're going through those eye walls and eyes are the big places that we would release sondes. Eye walls to capture the surface winds. So now there's an instrument on the plane that helps read surface winds, but we used to do this by eye. So we would have to remember that hurricanes are not perfectly cylindrical. The wind core slants out as it goes up into the atmosphere. So you'd find your wind core at the flight level and then try and go in a little bit and guess where you could release the sonde to actually capture the max winds at the surface. And then in the eye, it's really used for the minimum pressure. So that's how those sondes are released. So that's what the plane would be doing, trying to guess where they're going to capture those winds below, and then flying along the pressure curve as they do all of that. And that's what the sondes look like. So as I said, the cardboard is in theory biodegradable, but there's metal instruments inside. They cost $600 or $700, so they are expensive. But when you look at the value to the public, and I'm an environmentalist, so I wish it was more recyclable, biodegradable. But when you look at the value to the public and all the lives saved, when we can kind of hone down that data, it is worth it. So that's what it looks like going in. When the meteorologist thinks it's in the right spot, they'll say release. The load master releases it, collects the data, and helps QC it, because the meteorologist is busy with a lot of other things. And then they'll send it over to us. We'll look at it too, and then we'll get all that data off to the Hurricane Center. We also, and we've done this a lot with the Navy recently, have been helping release buoys that will sit in the water and do research projects to include data as hurricanes go by. If a hurricane tends, buoys are different because the buoy stays more in one spot and the hurricane has to just happen to hit it. Whereas a plane, we can chase it down, but the buoys can bring in a lot of really valuable data as well. So when I said we used to have to do all the winds by eye, and I told my story about Hurricane Charlie, this is what the winds might look like. So you're looking at how green is it? You can maybe pick up a little green in there. How big are the white caps? Is there streaking? If there's a lot of winds, the white caps will start to streak. They'll do a shattered glass effect. So looking at all those different impacts, that is 80 knots. And that's something all of us used to know by eye. But sometimes there's clouds under you or other things, and some people were better at it than others. So as of 2005, there is an instrument that helps read that, which is invaluable because it can read it through the clouds, and it helps also target precipitation, called the Step Frequency Microwave Radiometer. And it basically uses the wave action. It kind of reads the bubbles, so to speak. So however much energy there is, it's able to read that and give us a wind speed estimate that is relied on very heavily now, because using this instrument let us find that it used to be a rule of thumb that if you're at 10,000 feet, the winds at the surface would probably be about 70% of what you were getting. And we started finding that the winds at the surface were even higher than being estimated before we had something to measure them. And that's kind of what it looks like. So the flat line flying in would be, normal atmosphere. And then when you get the spikes, it's reading that there's that difference in the brightnesses, and it's able to tell you what the winds are. I know that's complicated, but that's how we're reading the winds now. So there's the tracks versus the eye walls. Okay, I'm going to catch up on questions for a second. Can you circle in the eye? And if I don't get all of these, there's a lot of questions. Can you circle in the eye? Yeah, you can. So not maybe in that 5 mile eye I described, but a lot of them are 20 or 30 miles, and some are even bigger than that. Sometimes people do it just because it's gorgeous and you want to take pictures, and there's a stadium effect and everyone's oohing and eyeing. It's not 100% work all the time, and we also get to enjoy those beautiful moments. It would always frustrate me as a meteorologist, though, because when everyone else would be in the front oohing and eyeing, I'd be in the back on my computer, like, trying to make time to run up to the front and look at it. But yeah. So yes, Scuttlebutt there's a list to get a ride on the plane. If you're media, there is a list. Now it is somewhat prioritized, not necessarily first come, first serve. If you're national media, you probably get higher, because part of it is to get the reserve mission and the military mission and the word out. So if it's a media that has more reach, that might get a priority. Or if the storm is headed towards Houston media would get a priority. But other than that, it's fairly first come, first serve. So there is a media list. You can reach out to the 403rd Wing, which is where the hurricane hunters fall under, and their public affairs. You can find them on Facebook and ask to get on that list. Let's see. Okay, I think, Brian, am I missing any major questions?
No, and we'll catch up with them when you finish up.
Sounds good. Okay, I'm gonna keep going. So speaking of those victory laps in the eye, so here's just a couple pretty pictures. I think a number of these might be Katrina, but we've gotten these out of numerous storms. And really the most gorgeous ones to me are, sometimes they don't show as well in the pictures, are the night ones, because you've got the stars above, you've got the clouds around, and in some storms you have lightning. I don't think we have a great picture of that in here, but I just today had someone ask me about lightning in a storm. And while tropical storms tend to be less dynamic in that respect, especially a rapidly intensifying hurricane, I have seen, and it's there, a lot of lightning in some storms and hail. In 2005, so someone asked me if we've ever found dings on the plane when you land, and I was like, when we land. In 2005, I was flying Hurricane Emily, which a lot of people don't remember because it was in the Caribbean when it was Cat 5, so it didn't do a lot of damage compared to some storms. At the time, they thought it was a 4, but in post-mortem, it was upgraded to a 5. And I will say that was one of my roughest flights, because for the 6 hours we were in the storm, a lot of times it's the eye wall, right? That you've got bumps going in and bumps going out, and you're kind of getting tossed around in the eye wall. And I have an iron stomach, so this doesn't bother me. But Emily was 6 hours of just getting bounced around, and then worse than the eye wall. And it wasn't so much that I was nauseous, it was that after 6 hours of getting just jarred around, I was just exhausted. So, but that storm was rapidly intensifying. I flew it a couple of times, but one of the times I was in there, it was rapidly intensifying. And the pilots use what's called hot mic. So all of us have headsets on with microphones, and most of us push to talk. So if I want to say something, I push the thing and I can talk to everyone. The pilots, because their hands are busy, usually use hot mic, which is sound activated. So when they start talking, the microphone just picks it up. There was so much hail at a point during that storm that the bang, 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 I was like, what is that noise? And it was the hail hitting the windshield was getting picked up in the pilot's microphones and transmitting it to all of our headsets. So it was crazy hail, a lot of lightning. So you do get that in some storms. Another flight I was in, there was only a tropical storm. We actually took a lightning strike, which happens in planes, but that particular one got into some of the systems versus usually, you know, the lightning kind of goes off and doesn't cause problems. That one took out our radar, and someone had asked about, here's just a couple other pictures as I chat. That one took out our radar, and without radar in a storm, we had to turn around. And I had to be communicating with the Hurricane Center to be like, okay, we were out near the Bahamas, but that's what, 700 islands. To have them try and find the nearest radar and make sure we were picking through and not flying into something bad, because we were pretty much blind without the radar. So the lightning can cause problems, although it doesn't happen that much. It definitely can happen. And there's one of the night shots. As I said, I've seen some even more gorgeous ones at night with the lightning kind of rotating around the eye wall. So this is, I believe this one is Katrina, but that's what it'll look like. So someone had asked if the radar is our radar on the plane, and it is. That was one of the reconfigurations that they had to do with the J model, and previously when we were using the C-130H model, is that most radars for aircraft is avoidance radar. So if something's ugly, it paints it hot and you stay away from it, and that's the thing. For us, clearly, we have to go through it. So they had to get in, for our planes, a more nuanced radar and do a lot of testing with it to make sure it would show us the bad spots. There's a flashing mechanism on where it picks out areas that they think there's more lightning in or turbulence. So there are some unique features, but that's why this particular image is only showing half of a radar, because it's what's ahead of the plane. But once you're in there, you can see, so sometimes it can be hard because of the eye wall and how it is to see everything until you're kind of in there. You know, whether there's going to be a second band and then eye wall replacement is going on, or something of that effect, you might not see it until you're almost right there because of the way the radar works. And this one is from Harvey, and I'm going to give you all just like 30 seconds to look closely at it and see if you can find something fun in the radar.
Fun.
Fun. Okay. If you look, the circle, which is where the airplane is going, if you look to the right of that, I don't know that my cursor, does my cursor show up when I move it
Yeah,
around?
yeah, we can
Oh,
see
good.
it.
Oh, good. Right there.
Oh, look, yeah. Mhm.
That is a tornado. So that is one of the other things that you can have in the eye of a hurricane. When you're way out in the middle of the nowhere, it's more likely to be maybe a water spout off in the distance. But this is as Harvey was starting to get closer to landfall, and especially with the friction going into landfall, this is something we would have to watch out for. So yeah, so that's one of the reasons that there's a navigator in the plane, because the navigator, while I'm busy going, go left, go right, and that's what we're doing in the storm. The vortex center of an eye of a storm, where the actual spot, the winds twist, is not going to usually be in the dead center. Sometimes it's kind of close to one side of the eye or the other. So one of our jobs in the storm, and if it's 30 miles across and it's really kind of hugging the left side, if you just assume it's right in the middle, you could be 10 miles off. So part of our job is, once we get in the middle, using the winds to steer and saying, pilot, go left 10 degrees, go right 20 degrees, to get us to where that actual winds flip around and where that center of the circulation is. Because if we're even off 10 miles right now, which might not seem like a lot, as the models go forward, that compounds. So we're busy steering and watching for stuff on the radar and typing up our reports and making sure the sound release is going. And so that's one of the reasons we have the navigators, because the navigator is doing these cuts, and then, you know, we can say, hey, take a closer look at that. And, you know, they'll give us some radar slices, and next thing you know, you're finding a tornado. So clearly that's something that would kind of change our route a little bit. We would steer around it, but those are some of the things that you have to be mindful as you're going through a storm.
So Nicole, part of the issue is, just on the point, is that the storm is not always a cone, right? It can be tilted. Right. So sometimes what you're looking at your flight level is not where the center is at the surface. So you've got to think about that kind of thing. And that's what we're trying to figure out, right?
Yeah. So we're seeing our slice of the atmosphere, and we release based on flight level. So we're finding the flight level center and dropping it at the flight level center. And then, you know, you're hoping that it gets near this storm level center. There is actually, if we're able to see the surface, one of the other things we're supposed to be doing at the same time is trying to watch for like a calm area on the surface where we think the surface center might be. And if we happen to be able to see that, then we would also kind of fly that direction and give those coordinates, or say, you know, we're seeing that a mile to the left, or whatever else. So, right. So dropping the sound at flight level, and that's where we are supposed to do it, isn't going to perfectly capture it, but it'll give you enough of the winds on the way down that they can also do some extrapolation of pretty much where it's going to be when you look at the winds and the speeds as that sound is dropping.
Right. If you look at the vortex message, it'll say what the winds were near the surface. So if they have winds, they know that it's not right in the center, and they'll accommodate for that. Right.
Correct. So why do crazies go fly into storms? Because some of us really like adrenaline, but more importantly, because it makes the forecast more accurate. So these storms develop over water. They spend most of their lives over water. And unlike over land, where we can send up weather balloons and we have radars and everyone has a backyard weather station, we don't have that over water. If it passes over an island or happens to get close to a buoy, great, we've got some data. Satellites, some of the satellite images we see, you might look from above and see like, oh, it's going to be there. In fact, we've gotten coordinates where the Hurricane Center will say, okay, we think it's going to be there. These are the coordinates that you head to, and we'll find it 60 miles away. And what kind of looked like it on satellite wasn't it. So, because you're looking from above. So all of the data that we can get by actually going inside improves the forecast significantly. And that means that hopefully we have less of this, which is, you know, models that go all over the place. And instead we can target. So this is looking back at, I think this was Ivan. But with the data, and, you know, that was still a wide swath, but it would be even more so without that. I don't know if they've recalculated this, but it used to be $1 million per mile that was evacuated. So anything that you can narrow it not only saves money, so the cost of the $700 sonde is nothing compared to if you can save some of that evacuation area. But to me, more importantly, they have done studies. I remember in 2005 and 2006, they said, who's ready for hurricane season? Everyone was ready because 2005 was crazy. And then in 2006, was quiet, and they did the same survey in 2007, and the preparedness had gone down by like half. So the more that you can target and get the right people out, so that people aren't kind of going, oh, they evacuate us all the time. The more that it's targeted, the more that people tend to take it seriously. And I think that really helps the public when you're able to kind of narrow that so that people know, okay, I'm really the one under this. I'm really the one that has to go. Because of course, before we had all this data, before we had satellites, you know, it could be a major loss of life if people didn't know it was coming. So this is the Galveston 1900, where up to 10,000 lives, and it was estimated, were lost. And so the hurricane hunters help collect the data, working with the Hurricane Center. The Hurricane Center puts out the forecasts, and then it's up to all those individual communities and emergency managers and local officials to help like get out the word and manage the evacuations and everything else. So this is Katrina, and this to me is another good example of why we do that. So Katrina, not only did I fly it, but it was a very personal storm because it hit our base. And if you remember, it cut across southern Florida. So this cone kind of shows that. And then I was at the Weather Channel at the time, and it was a Friday, and I was going to go down and fly over the weekend and help with the storm. And as of when I left, if you look at this cone, everyone thought it was going to go over the panhandle of Florida. So I hop in my car for the 6-hour drive. And as I'm driving, one of my fellow hurricane hunters called, and she was like, do you know we're evacuating? And it had changed that much while I was driving. So that's another look at the cone. Again, I'm kind of leaving Georgia, and it doesn't look like it's a big deal, but you have to look at the whole cone, not just the southern line. So Mississippi was in it, but yeah, and then it changed a lot. So I ended up flying it that Saturday night. It made landfall again on Monday morning after the southern Florida panhandle landfall, and evacuated with the plane. So the plane ended up in Houston. I had to get a commercial flight back to get my car. After flying all night Saturday, caught the last flight into Mississippi Sunday morning, got my car, sat in evacuation traffic to make it back into the Weather Channel by that Monday morning to be on air. And then I was like, we're not doing this again. If I get evacuated, I'm just gonna have to stay with the group. But yeah, the storm pretty much leveled a lot of our base. And it was hard on the crew, like they're all hard, but that one we could see, it wasn't just that it was intense, it was the winds went so far out that we knew it was gonna be a big storm and a lot of storm surge. And so we knew there was gonna be a lot of loss of life. So it was a pretty somber flight because, you know, people knew that they possibly personally were going to be losing houses or people they knew because of the storm being so intense. So that's a closer look at that one. And then of course, Sandy, a few years later, was far less intense, but it had such a wide field that, again, that's part of the reason we always encourage people not just to look at the intensity in the center of the storm, but how big is this storm? What sort of field is it going into? Is an area that's really susceptible to storm surge, things like that. So a couple more pretty shots. And then that was our base from the ground. And that was the community and the after. Okay. So that's what I have. But again, I am happy to answer any questions that you guys have.
So Nicole, there are lots of kind of technical questions here, but just starting with a comment from one of the viewers in the Q&A, says that's a very inspiring talk. Would you mind talking about how you juggle this kind of job and the demands of motherhood?
Sometimes I feel like not well. So I have a 4-year-old, and I'm actually a foster parent now. So I have a bonus 4-year-old currently. So that is part of the reason I'm not hurricane hunting anymore. I have 28 years of service, and I've done 16 with the hurricane hunters. And I was very clear, like, I gave the military a lot of times where I would drop everything and do whatever. But the military does have a goal of trying to be more inclusive of families, and especially single parents, and retaining women after they have kids. They found that there's a huge problem. So once I had my child, I was pretty admittedly like, look, we're going to work with this, or, my child's going to come first. So I got daycare in Mississippi. He would travel with me. And I had someone I trusted when I would go on an overnight flight. I took less of the remote assignments. So when I talked about those other bases, I would be more often to say, like, hey, don't send me to Hawaii. Let me stay and work and fly the storms out of Mississippi so that I can stay with my child. And so we did that up until he was 3. But then as he was starting to get in preschool and everything else, I didn't want to be traveling so much. My child has frequent flyer miles. We were traveling so much, and he's a great traveler now. But so I was offered a commander position back in the National Guard, which is where I'd started. And I took it, which lets me be closer to home and not travel so much. And I hopefully get to make a different sort of impact now, trying to be what I hope is a good boss, and making sure, everyone, at least around me, has a good experience and a good footing in the military.
And going back to the beginning, so you're now in the Air Force Reserve, but did you go to university as a meteorologist, or what order did these things come in terms of your meteorology versus your military training? Yeah,
so I'm kind of the oddball. I got into, I did my last year. Minnesota has done this for a while, where you could do your last year of high school and take college classes. And I was going to have to pay for college myself. So I did that, and I started off, I loved science. So I started off pre-med, and then I missed doing, I'd done speech and declamation, all those things in high school. So I switched to journalism and or communications, and still missed science. And then once I had to pay for college myself, once I was out of high school, my parents had been in the Reserve and Guard as well, and were like, this is the way to pay for school. So what they offered me, weather just sounded interesting, because I love to camp, I love to be outdoors. And I was like, okay, that'll be fun. And they said the school was short. It was really just the observing school was short. And then when I had to go back to the full forecasting school, of course, it was much longer. So it was about a year of just weather. So I came out of that with their degree, and then concurrently I was getting a communications degree. So those are my 2 degrees. And then randomly later on in life, I went and got a law degree. So when I started working in TV, I was more on the journalism side, but then doing weather for the military. And because the military weather could be very stressful, which I'm okay with. I just didn't know that I wanted to do it all the time. It was like, can planes take off and land? And is there fog? And is there enemy fire coming in that they're going to see because of the clouds, and just stuff. So once I got into the TV side of it, I was like, oh, this is really fun. And you get to communicate with the public. And so that's kind of how I ended up merging the 2. And then as I moved for my television career, I had been in the Guard, and I got to a location where there weren't any Guard military jobs nearby. And I knew about the hurricane hunters, and there's only, again, 10 slots at all for reservists, traditional reservists, and I managed to get one of them. So I stuck with it until life changed.
Wow. Yeah, it's amazing how you just never know. So many things can happen in so many directions. My situation is very much the same. I ended up doing this, but I didn't expect to be doing this. So a question we got by email from a viewer was about your most nerve-wracking or hair-raising flight. You talked about Emily, but how often are flights like really annoying as opposed to, kind of routine?
So, I'm the bad person to ask that question anyway, because I will admit that a couple of my pilot friends used to joke that while they would be at the front, like white knuckled when we would get into something bad, I would be the one in the back going like, "Wee," as we're kind of flying through. So the eye walls, you use a big sturdy C-130 because, if you're flying in the jet stream, you're going to be getting winds over 100 miles per hour anyway. So that's not actually the problem. So we just kind of do it so that it's off one side pushing us on the way into a storm and the other way on the way out. It's more the turbulence, the up and down, or as I said, in Wilma, where they'd gotten so far down that if a downdraft hits you from above and you're too close to the water, you're going to end up in it. So, I've had a number because I flew for 16 years, but then there were a lot of days where we were doing an invest and it was like beautiful skies and there's a sailboat going by and you're like, I don't think there's a storm out here. So I would say the rapidly intensifying storms that were a little bit bigger were the big ones. And then number two, I flew Faye a couple times. I told about the time where they kind of called us off and I don't think they wanted to make it a storm quite yet. We also flew it when it was over part of Hispaniola, which had mountains. So if part of the storm is over land and especially high terrain, then that makes the whole thing, puts turbulence through all of it, even if it's a tropical storm. So those are what I would say the couple times, rapidly intensifying. And even versus a category 5, I've done a few category 5s, and if they're just kind of steady state, they're not so bad. But rapidly intensifying and terrain, those are the two big ones.
So you talked about the Wilma experience. I remember Wilma well when that Ob came in with that very small eye and the 882 millibar pressure and all that kind of, it was like, oh my God, this season never going to end. But at that time, was there a difference in the radar on the plane? I mean, now you have, tail Doppler radars and there's Doppler radars. So comparing 2005 to now 16 years later, would you have better information now as you're flying, toward the eye of a storm about what to expect ahead?
I don't think it would be significantly better because so part of what happens is it's consistency. I think they were one of the first flights in, and especially if you're one of the first flights in, or if there hasn't been a flight in say 12 hours, because we're talking to each other all the time. And when you get a storm that's about to make landfall, then one fly's coming out and one's coming in, and we'll even say, hey, we flew it at 5,000, but you probably want to go up a level. Or it really wasn't bad. You might be able to go back down a level. So there's a lot of communication that way. So I don't know that there would be significantly better because the NHC is basing a lot of their stuff on satellite data to include, the satellites that are able to do the wind estimates. But I don't know that that has improved significantly enough that you wouldn't have that similar situation, especially given, if I remember correctly, there was a gap in planes. So they weren't able to warn each other that the storm was doing that at that time.
Yeah, I guess what I was wondering is to what extent does the radar on the plane kind of alert you to, the size of the eye that's ahead, or, how much range do you have as you're flying, toward the eye wall?
Well, so the radar in the plane, if you've got a lot going on, it's going to be able to get through it a little bit, but it's only going to be able to see so far forward. And I think like that example, They didn't think it was that bad. They went in at 5,000 feet. As the pressure is doing this, they're getting more and more in it. And once you're that much in it, you really can't climb at that point,
Right.
especially without compromising the data that you're in the middle of getting.
Yeah.
So I don't think they would have known soon enough. And then once they were in it and saw what was happening, they were kind of committed.
Yeah. That example of Faye that you talked about, I wonder if over time the Hurricane Center protocols have changed now that there's so much data coming in.
Yeah.
You know, we have so many different ways of analyzing storms now with the new satellites and so forth. Seems like they've, you know, they're pretty much like whatever it is at the time that it is. Now, do you have any sense of the protocols evolving with time? I know way back, I remember talking to Neil Frank, way back, if they were super busy, there was a storm way out there and it wasn't bothering anybody, they wouldn't even really jump on it. You know, it was much more loosey-goosey. It just feels like as more and more data has come along and you get more real-time data that, you know, they're pretty much on it. Do you have any sense of it having changed over time?
Yeah, I do think it has. And even if you look at the fact that like subtropical storms didn't used to be named, or we've seen them over the last decade to 15 years be now getting pretty consistently named. And so I don't know if it's just a change in philosophy at the Hurricane Center. There is more data. I think there's also more interest. You know, we're in a never-ending news cycle,
Right.
And when you get all these media that are asking questions all the time, even a storm that's now out there, you might feel more compelled to do more on, even if it's not a threat yet. So, yeah, so I think there has, and it's been interesting because, you know, we talk now about a season with higher numbers than ever before. But again, we have to go back to that. Before the 60s, we didn't even know what was out there because of the satellites. And now we're naming more things. And so, yeah, it's been interesting to see that evolution over time of, I think, maybe being even more overcautious and making sure that everyone has all the information because it's so many people do follow it.
Yeah, and in 1933, if you go back and look at the track map, the whole western side of the ocean over near the United States and the Caribbean and whatnot is full of storms.
Yeah.
And the eastern side is empty, and nobody thinks the eastern side of the Atlantic was totally empty that year. We just didn't have anything out there monitoring it. And now everybody can sit at home on their computer and watch the data coming out of the hurricane hunters and monitor all kinds of satellites and everything. So I think that you're right. The pressure is on to, you know, be as straightforward as possible and analyze every bit of data that comes in. It's kind of amazing. Just on a very basic level, talk about, to me, this whole system we use for invests and numbering them and whatnot is really kind of arcane and confusing, and really is not very public friendly. You know, in the Atlantic, 90L to 99L, and then we start over at 90. So talk about the kind of details of that.
I think it's confusing too. Yeah, there's storms like, and I think Katrina was one of them. I think that year it was number 10, and then it technically lost its center. So then there was something in between. Now I'm going back to 2005. So if my memory is not crystal clear, please do not flame me for it. But I think it technically lost its center. So then it came back as number 12.
Right.
And then
tropical depression. There's tropical depression number 12. Right.
Yeah. Yeah. And then the 90. I don't.
Yeah, it just happened. That happened right offshore here. I'm in Miami, and so that was just over there by the Bahamas, because at the time they were trying to tell if the circulation of 10 regenerated or if there's something else involved. They decided something else was involved besides 10, and so they made it 12. And but it is a odd thing the way investor number. There's in the Atlantic, L for the Atlantic, because A is the Arabian Sea, and they start at 90 and they go to 99 and they go back to 90. someday I hope they do
Yeah.
better than that. In terms of dropsons, do you have any sense of how many dropsons on an average mission do you drop? Is there an average number, or is it totally storm dependent, or how does that work?
Well, so typically what a forecaster is going to ask for is, okay, so I'm basing this on what a typical is, which is 4 passes through the eyes with those 2 X patterns. We call them alpha patterns. So 4 passes for the eyes. So minimum of 4. Now, if you're low level and INVEST, you're so close to everything, they won't even release any. So it's not until you get to the higher levels that we use them. And then it depends on how many they want in the eye walls. So if they want one in each eye wall each time, that's going to be another 8 with each pass for 12. We used to have a hurricane center person that we called him the mad bomber because he would always ask for extras. He'd ask for ones at like endpoints and to really get the whole field. So it's going to depend. It's also, we also cut off legs sometimes if we're right near land. So, or someone might just want a lot of times the northeast quadrant is going to be the most intense. So maybe they'll say, we just want the northeast or just the northeast and the northwest. So it's going to vary a lot, but definitely you're going to have the 4 for the eye. And sometimes if we have really short legs and it's close to land, because we're not doing one side, sometimes you could pass through the eye 6 or 7 times. So the eyes for sure, and then however many times they want those eye walls.
Yeah, I think in general now, don't they have a protocol that they always do the endpoints of the alpha pattern? I think they do the corners now, kind of by protocol. No, the C-130s, that's that's your hurricane hunters, but NOAA sends out a couple of P3s, generally research, but also kind of provides a similar service at times. And then there's the G4. So somebody put a question in here about the G4, that is the high flying jet. How's that data incorporated with the data that your hurricane hunter would gather?
So the Air Force Reserve hurricane hunters do, I think, at least 80, sometimes up to 90% of the actual like workhorse storm missions where you're going to fly in inside the storm and take the data, just like I've described. So NOAA would do the extra 10 to 20%. And usually it's kind of the flights that they want to get involved in. But they do other research sort of things. So either, if they're flying high, it could be upper atmospheric stuff. They could be releasing more SONs in different areas. Sometimes they're doing low level research. One interesting story, and this was from just before my time, but there was a NOAA flight back in the early 2000s that they were doing all sorts of things to help figure out these storms. And they were just flying in between rain bands. So, but they were higher, I want to say at least 1,000 feet. So they weren't like right down in the water where they'd be in the salt spray. And they were just flying in between rain bands. And if I remember correctly, there was one of the reserve hurricane hunters then also just flying a storm nearby. And the planes have 4 engines. So they lose an engine. They're like, okay, well, that's weird. And then they lost another engine. And they started getting very concerned and started flying towards home. And I don't remember if they lost another one or not, but they were like in a bad shape. And I think they had called the other plane to say, hey, can you help steer us out? So we're going to try and get home. We don't know what's happening. We're just losing engines. And at some point they finally, because they abandoned their mission, because they were losing engines, they ended up flying through a rain band again, which they hadn't been doing, and an engine fired back on. And they started realizing that as they flew through the rain bands, the engines were starting to work again. And when they got back, their engines were just encrusted with salt.
Right.
And so that mission, even though they were high enough out that they thought that they were out of the salt spray, had been encrusting their engines and making them die, and they almost lost a plane because of it. So just a tangent story, but that some of the stuff that people do is, can be riskier than you think it's going to be. But those are the type of different things that they will do. Investigate rain bands, investigate in between rain bands, upper level stuff, winds around the storm, all sorts of things. Because
yeah, the hurricane's an opportunity, it's a laboratory actually, and so the P3s go out and investigate a lot to learn, right? And the G4s fly high and really on the perimeter of the storm, right? It's a jet, it's a NOAA jet that flies around the perimeter, not through the storm.
Yeah, correct.
Right.
Yeah. So, and people ask us that too. They even think we fly above, and we're like, no, there are some planes, the G4s, that do that and are getting, different types of data, but the Hurricane Hunter planes are right inside.
So John Alquist at FSU asks a good question. I think a lot of people have these days. The big drones that NASA sends out on occasion into storms. Do you think drones are going to replace hurricane hunters over time, or is there always going to be a role for humans in the planes going into the storms?
I think it could happen at some point. I don't think it's going to necessarily happen in the near future. Because there still is a lot of human interaction in it. So as I said, when you're getting in the eye of the storm, are you going to be able to coordinate back with whoever is running, the joystick on the drone, so to speak, to see those wind nuances and be able to steer exactly where you want to get that center? And then how are we going to release the sonde so that we can get, because the plane is getting the vertical, the sonde or the horizontal, the sonde gets the vertical, and between the two we kind of have a 3D. So, are we going to put instrumentation on sondes, things like that? So I think we will get there at some point, and just looking from while it will be sad because I always enjoyed the job and many people do, from cost effective, from potential risk to humans and things like that, it would be better to get to that point at some point in time. But right now it is nice to have, until the technology gets even better, a set of human eyes being able to, look at the radar, see what that is, see that little tornado that we found, all those things.
Yeah, I think part of it is how good the sensing is on the drone, and to what degree there's real-time delivery of the data back to somebody controlling it. So there are a lot of, I know what I wanted to ask you about. I wanted to ask you about the issue of looking out of the plane and estimating this wind speed from the way that the sea spray looks and the waves look. Because back before, I don't know how many years ago it was, that was the way it was done, right? Because one of the things that the Hurricane Reanalysis Project has done is gone back and said, well, they overestimated it on that storm based on all the other data, because that's how they were estimating it. They were looking out and looking at the waves. Were you, so did you have a class in that where they show you a picture and they say, okay, that's 80 knots, this is 60 knots, and so forth? How did you learn to identify the sea state, look and equate that to wind speeds?
So we actually have a chart. Now, I don't know for sure how that chart was put together. I would assume they probably used in fact, my Charlie one, the first question, they were like, did you get pictures? And this was before we all had the cell phone cameras. And of course, while I'm watching this gorgeous, because I don't think many people ever, because it was a bad idea, had been at 500 feet seeing 70 or 80 knot winds. So they were like, oh my gosh, did you get a picture? And I was like, my camera was in the back of the plane. And I didn't want to, I knew it was going to be so short that I didn't want to run, get the camera and then miss, seeing it. But so when people were able to get pictures, and I'm sure they were using sondes to kind of verify some of those winds, and especially if you're at low level. So like we were at 500 feet, you're so close to the surface, you can verify a little bit off the winds the plane has seen itself. So that combination of things, then there was a chart that we would use, and it would be like, are you starting to see white caps? Are you starting to see the white cap streak? Are you starting to see like green blobs within the water, which is more aeration? Are you starting to see the white caps streak because the wind is blowing them? Is it shattered glass? Which is, you know, all these levels are kind of getting higher. So we actually had a chart. And then once you've done it a few times, at least for me, I'm a visual person anyway. So once I'd done it a few times, and I was like, oh, that's that. So.
Is flying into winter storms any different than flying into hurricanes in terms of the ride or the protocols or you know, what you do?
Boring, no. So winter storms are, the meteorologist is really taken out of it a lot. In a hurricane or a tropical storm or anything else, you're given coordinates that are an estimate, but you're the one that has to actually find the center of the storm. You're the one that's saying, this is where we need to release the sondes. Like you're running the show. For a winter storm, they give you a grid and you're just making sure you get to the coordinates, which the navigator is plugging those coordinates in for you. And once you get there, you're coordinating the sonde release. So like every half hour you're going, okay, release sonde, and then you go back to your book.
Yeah, because there's not a center, there's not an eye in the same sense that there is in a,
yeah. So you just have a check. A winter storm is almost more like a checklist to make sure you're getting all your sondes in the right place. But there's not a lot of actual meteorology that you're having to do, or you know, autonomous thought that you have to put into it, other than making sure all the data is correct. Part of the job is quality control. So you're making sure all the data makes sense. But yeah, it's far different than a hurricane.
So you talked about, you know, going to Hawaii, going to St. Croix, and Hawaii is sort of the extreme version of going to St. Croix, right? It's a long ride out there. But I remember a storm, was it Lane or some storm fairly recently that they, you know, hurricane hunters went out there, or maybe they sent the P3 out there, I don't remember. But the point was that the problem was that the storm was going toward Oahu. And so the plane had to leave because there's no place, if the storm is coming toward the islands, there's no place safe to put the plane, right? So the plane had to leave. Are you know, flights to Hawaii, have you done Hawaii? Is it like more complicated, more difficult, more annoying?
No, not really. The only thing is, like your colleagues back at your normal job were like, "Oh, you're in Hawaii," and I was like, "I was working 16-hour days." Hawaii ones could be challenging because a lot of the storms actually die out before they get there. So it's in a slow C-130. It was always a lot of getting there to, once you've done all that and dragging bags and equipment and everything else, to, okay, are we actually going to have anything to fly by the time we get there? So there were a number of times, even by the time we got there, it would die out. But because we would have to get in place, we'd have to go anyway. In fact, there was one time we were leaving Keesler and I was looking at the satellite watching the storm fizzle. And I called the Hurricane Center and said, do you really want us to go? Like, this doesn't look good. But Hawaii is run by the Central Pacific Hurricane Center. And that forecaster, it was the middle of the night. That person wasn't available. So all the planes had to go. And then halfway to California, like, okay, everybody turn around. So that's more the Hawaii thing. I remember what you're talking about. I don't remember what storm. I wasn't on the one that had to evacuate. But I can tell you they evacuated to another island. So it's not like they had to evacuate back to
I see. Okay.
Yeah, they ended up going to another island. And the same thing with St. Croix. There's times we've had to evacuate St. Croix and go to a different island, or we'll kind of retreat to something closer in the United States, like maybe Florida. That's still
Miami sometimes, or Lakeland or Tampa.
Or another Caribbean island. There was one time I know for sure they ended up with planes stuck in St. Croix with a storm that was stronger than they thought it was going to be, and they took off in the eye because that was the only way they could get out and fly and then recover somewhere else. But yeah, so there's a lot of repositioning going on if the storm comes where you are.
Yeah, I remember that. Remember that story. But you go to St. Croix, am I right, to position for storms that are farther out east of the Antilles?
Yeah.
So to get data on storms that you can't fly in one hop from the United States, right?
Correct, because there's, as I said, there's technically 14 some hours of gas, but you don't, it's not like
Yeah.
your car
Right.
where, you know, if you run out of gas, you just pull over. So you don't want to fly over 13 hours, keep an hour buffer. And I've flown over 13 hours, it's a long day. But you don't want to waste all your gas getting there, and then you don't have time to explore the storm. So that's why we sometimes move to closer locations.
Yeah. So there are a lot of questions in one fashion or the other related to becoming an Air Force Reserve pilot or a hurricane hunter pilot. What is the average process? Not so much how you did it, but how most of the pilots you fly with, you know, become hurricane hunter pilots.
Most of our pilots, so we did have a few that directly came off the street, so to speak, and commissioned into the hurricane hunters, but most of them were previous active duty pilots or pilots somewhere else that already had experience and then came in. So, you know, going into the Air Force, predominantly Air Force, but some of them had come from other branches as well, and then coming in that way. Although occasionally they would have boards for people who had never been a pilot before to get a commission, but even then having some military experience was better. So we had at least one meteorologist that went and became a pilot, one of our navigators had become a pilot, some of our maintenance people. So people that kind of at least have some sort of experience did have a leg up on getting those pilot slots if they'd never been a pilot. And then of course, first choice is picking someone who's already trained and been doing the job.
And as you say, many do come out of the military, right? And because they go into the reserves after their tour in the military, and yeah, full time. And how many of the people involved that work out at Keesler are meteorologists that are in the Hurricane Hunter program? Or is it just a, you know, like one per crew, or no? I know that because I know one of the FSU meteorologists became a pilot there, so I know some of the pilots are meteorologists, as you were. But how many of them? How many meteorologists are involved in that program? Do you have a sense?
So I just want to clarify. So there's, you know, the job of meteorologist, and then there's the job of pilot. I was a meteorologist. We did have at least one or two pilots who that happened to be their degree. For just meteorologists within the Hurricane Hunter, just 20. And all the crews are half, so like all the pilots are half full-time people and half traditional reserve is what they called it. So people that did the part-time and then have another job. So 20 total, 10 full-time, 10 part-time. And then what would happen as a flight would come up, you mix and match a crew. So a crew would only have one meteorologist unless there was someone in training, and then you'd have the instructor and the training.
I see. Okay. All right. So generally, people go into the program as a meteorologist or as a pilot. And generally, they kind of go into a slot there, right? Or perhaps as a navigator.
Right. Yeah. So it's, no one does every job. There could be someone, as I said, we had a meteorologist that decided that they wanted to be a pilot. So they still had to apply to be a pilot and completely switch jobs once they got that pilot slot instead. And then we've had, you know, pilots that for whatever reason couldn't be a pilot anymore, that then might step back into a different job. But your job at that time is your job at that time. So yeah, we don't mix and match, so to speak.
All right. Well, you've gotten overwhelming number of comments here, thanking you for your service and the great talk this afternoon, the inspiring talk. Hi, buddy. How you doing? And so we appreciate it very much, and you know, it's been great knowing you all these years, and congratulations on everything you've done, and congratulations on your service to our country and to the program.
Hi.
Hi.
Thank you, Brian. Good talking to you, and thanks to all of you that joined us today. I hope you enjoyed it.
Hi.
You'll see all the comments are saved with this. So anyway, you'll get to see them. Lots of people really appreciate it. Thank you. All right. Thank you, everybody. And Thanks for being with us this afternoon, and thanks for all your great questions. Have a good day.